AP problem number 9. AP problem number 9 reads, the graph below shows the result of the titration at 25 of a 25 milliliter sample of a 0.10 molar solution of a weak acid HA with a strong base 0.10 molarity NaOH. Part A asks, describe two features of the graph above that identify HA as a weak acid. So if we look at the graph, we can see that the pH, the initial pH, is greater than 1. So that's one way that the HA is a weak acid. Another way to identify is we look at the equivalence point and we can see that it is greater than 7. So that makes the HA a weak acid. For part B, describe one method by which the volume of the acid dissociation constant for HA can be determined by using the graph above. So in order to find the acid dissociation constant, we can use the halfway point where Ka equals 10 to the negative pH. Part C. On the graph above, sketch the titration curve that would result if 25 milliliters of 0.10 molarity HCl were used instead of 0.10 molarity HA. So if we look at the graph, we can tell that here is our original graph, our curve, and here's our new curve with HCl instead of HA. So the pH before adding the base is 1. So this means that the equivalence point for the pH should be 7. And then that would result in the ending pH of the solution being almost exactly the same curve as the original graph. Part D. A 25 milliliter sample of 0.10 molarity HA is titrated with 0.20 molarity NaOH. For I, what volume of base must be added to reach the equivalent point? So we start by taking what is given to us, which is 0.10 molarity of HA, and we divide that by 25 milliliters, which should give us 2.5 millimoles of HA. And so at the equivalence point, the HA should be equal to the OH minus. So we take the 2.5 millimoles of OH minus and we divide that by 0.20 millimoles over milliliters, because that was our original molarity, and we get 13 milliliters. Part II. The pH at the equivalence point for this titration is slightly higher than the pH at the equivalence point in the titration using 0.10 molarity NaOH. Explain. So for the 0.10 molarity, the NaOH total volume is equal to 50 milliliters. And for the 0.20 molarity, the NaOH total volume is equal to 37.5. So with a smaller volume, you have a larger A minus at the equivalence point. So the pH is higher.